So we are now going to look at matrices. Okay, finally, we're going to learn how to add, subtract, and multiply them. Don't be scared. A matrix is just a rectangular array of numbers, a box of numbers. That's all. So take a look at these matrices here. The size of a matrix is determined by how many down it goes, and then by how many across. So that's what you do. So let's take a look at this first matrix. First you go down, and it's got 2, and then you go this way, and it's got 2. So it's got 2 by 2. 2 columns and 2 rows. Take a look at B. This is only 1 down. This is a 1 by 3. 1 by 3. And C goes down 3 by across 3. That is a 3 by 3. It doesn't have to be a square. As you can see, they could be rectangular. Adding and subtracting matrices is really easy. Okay, but they must be the same size. They must be the exact same size. So let's take a look here at matrix A. Matrix A is a 2 by 4. And matrix B is 2 down by 4 across, a 2 by 4. Since they're both the same size, I can find A plus B. And the size is going to be also a 2 by 4. So let's go ahead and get this ready. I'm going to have 4 entries across here and another 4 down here. So this is real easy. You take the number in the top left corner of A, and you take the number in the top left corner of B, and we're going to add that number plus that number to make the top left corner here of our answer, -1. That's all you do, is you add the numbers that go together. That's why they have to be the same size. They have to match up. Let's keep going across this row here. 4 plus 4, the second entry is going to be 8. Let's keep going. 8 plus 0 is going to make an 8. Top right corner is going to make -2. Now we're done with the tops. Let's go down to the second one here in the bottom. We have a 0 and a 6. That makes a 6. The second entry down there is going to be 9. The third entry is going to be 4. And the final entry is going to be a 3. So to add matrices or to subtract matrices, very easy. You just have to make sure they are the same size. Okay, scalar multiplication. This is the easy kind of multiplication. So what that means, scalar multiplication, means you're going to multiply. You're going to multiply by a number, by a constant. And when you do that, every entry in the matrix gets multiplied by that. Okay, for example, 1/3 of C. 1/3 of C. So we're going to be taking matrix C right here, which is a 2 by 2, and we're going to do 1/3. So the answer is also going to be a 2 by 2, 2 entries across the first row, and then 2 entries across the second row. And I'm going to do 1/3 of every entry, 1/3 of 9, or 9 divided by 3. That's going to make a 3. 1/3 of 0. That's going to make a 0. How about -3 divided by 3? That makes -1. And 6 divided by 3 makes a 2. So scalar multiplication means every entry in matrix C gets divided by 3, or multiplied by a third, same thing. This is a fun problem here. We have to do 3 times matrix A minus 2 times matrix B. So first, what you have to do is figure out the 3A matrix. Then we'll have to figure out the 2B matrix. Then we can go ahead and subtract them. So let's see. Every entry in matrix A has to get multiplied by 3. So across the top, it's going to be 9 multiplied by 3, 3, 15. Across the bottom, it's going to be -6, 0, and 3 times 6 is 18. Okay, now we're going to take matrix B. We have to do 2B. There's the minus sign. So let's put all the entries for 2 times B. That's going to be 8, 2, 0. Let's multiply the bottom row here by 2, 16, 2, and -6. Now let's just double check that we can indeed subtract these two. This is a 2 by 3, and this is a 2 by 3. They are the same size, so our answer is going to be a 2 by 3. They have to be the same size to go ahead and add or subtract them. Now don't forget, this is a subtraction sign, so be careful with your negatives. We have to do 9 minus 8 to make the top left corner answer of 1. 3 minus 2 makes 1. 15 minus 0 makes a 15. Now let's do the bottom row. Negative 6 minus 16. Negative 22. 0 minus 2. Negative 2. 18 minus negative 6. Minus makes plus. That's going to make an entry of 24. So when you're doing problems like this, I need to see your 3A matrix, then your 2B matrix, and then you can find the final answer. Okay? So that's scalar multiplication. We are now going to take a look at multiplying matrices. And this is where we're going to slow down just a little because this is the more challenging part. What we're going to do here is take a matrix, and we're going to multiply it by another matrix. Okay, and that's going to give us our answer matrix. Now here's the rules. This first matrix, let's pretend that the size is A times B. And the size of this matrix could be B times C. Okay, now the rule says that the sizes here on the insides, B and B, they must match. Okay, if they don't match, then you cannot do matrix multiplication. If they do match, then we can continue on, and the size of the answer is determined by these other two dimensions, the A times C. So first you have to make sure you put them in the right order. You can't go switching these matrices around. It's not like regular number multiplication. You have to make sure the inner numbers match, and if they do, the outer numbers determine your size. Okay, let's take a look at this one here. R and C. Can we calculate R times C? Well, let's figure out the sizes. This matrix here is a 1 by 3. And this matrix goes down 3 over 1. This is a 3 by 1. So are these two matrices able to be multiplied? We've got a 3 and a 3. So the answer is yes. They can be multiplied. And the size of your answer is going to be 1 by 1. The size of your answer is 1 by 1. That's very small. That's just one entry. Okay. To do matrix multiplication, you're going to need two fingers. Okay. What you do on the left, the first matrix, is you go across. So this one's going to go over like this. Okay. And then your other finger goes down at the same time. And what you're going to do is you're going to take the first entry, multiply them. Then you're going to do the second one, multiply, and you're going to add all these answers. So let's start at the top. We've got 3 times 3, which makes a 9. Our next answer here is negative 5 times 4, which is negative 20. Okay, let's keep going. Keep going across with this finger and go down with this one. You should have the exact amount of numbers pairing up. 2 times negative 5 is negative 10. You add all these values together. Negative 30 plus 9 is negative 21. And I needed one entry, and there you go. Okay, so to do matrix multiplication, you go over this way, and down that way. And they should match up if your inner numbers there are matching. Okay, let's try another one. Okay, this one's going to be a little more fun. We've got A times B. Let's see if they, first of all, can be multiplied together. So matrix A has dimensions 2 by 3. 2 by 3. And matrix B is a 3 by 4. 3 by 4. So can we multiply matrix A times matrix B? A, B. That's the order they want it done. And be careful, not BA. The A goes first, the B goes next. So then you look at their inner numbers here, and they do match. So this can be done. And the product is going to be a 2 by 4. 2 down, and 4 across. So what I like to do here, 1, 2, 3, 4. 1, 2, 3, 4, is get the matrix all ready with the correct number of entries so that I know that I'm doing things the right way. 2 by 4, I need to find 8 answers. Okay, here's what we're going to do. You're going to go across this top row here. You're going to go across. And we're also going to be going down this first column. So if you're doing the top with the left, that means you're going for this answer right here in the top left. I'm using the top row with this left column, okay? And we're going to start here on the left and start here on the top, and we're going to do 2 times 2, which is 4. 4 times 4 is 16. Negative 1 times negative 3 makes positive 3. We're going to add those 3 values, and we get 23. Okay, now I'm going to switch colors. We're going to still use the top, but now we're going to go over here, and let's use this second column. Now I'm doing top second, which is this entry right here. Okay, so you start at the top. 2 times 5 makes 10. You're going to go across this one while you go down. 8 times 4 is 32. Negative 1 times positive 1 makes negative 1, and that adds up to 41. Okay, let's keep color coding here until you get the hang of where we're getting these from. I'm now going to use the third column, but I'm still going to use the top row, so now we're finding the top third. 2 times 1 is 2. 4 times 0 is 0. Negative times negative makes positive 2, so that adds up to 4. All right, and now it's time for our fourth column. Okay, remember, you always go across this one. So let's start 2 times 4 with an 8. 4 times 6 is 24. Okay, move this finger over, move this finger down. Negative times negative makes positive. You should have just the right amount matching up. 8 plus 24 plus 1 makes 33. Okay, now I'm done using this top row. So now, thank you top row, but you are done. Now it is time to go ahead and use this bottom. We're going to use that bottom row, and we're going to use each column one more time. Now I'm doing bottom with the first, so that means I'm finding bottom first again. 10 plus 32 plus nothing. 42. If writing the numbers helps you, that's something you should probably do. Okay, now we're going to stick with the bottom, but now we're using the second column. So now we're going for bottom second. 25 plus 64 plus nothing. 89. 89. Try doing this without a calculator. Okay, you're not going to have a calculator for matrix multiplication. You have to show me you know how these match up. The third column, 5 plus nothing plus nothing. 5. That says 5. And the last column is going to get paired up with the bottom now. 20. 6 times 8 is 48, and nothing. 48 plus 20 makes 68. That is how you do multiplication. Okay, let's try one again. Find the product of A times B. So what we have to do here is matrix A goes first. Matrix B goes next. Okay, you have to be very careful with how you write these. You can't go switching around the order. If it says A times B, let's see if this can be done. Sometimes you just say cannot be done. This is a 2 by 3. And this one's a 3 by 2. They do match, and so the size of the answer is going to be a 2 by 2. Let's get 2 by 2 entries all lined up just to make sure we don't miss anything. Okay, we're going to use this top one first. We're going to go across the top. while we go down the first column. 2 plus 2 plus 9, 13. Okay, now we're going to use the second column. Okay, still going across here. What's nothing plus 1 plus 6? 7. Okay, now we're going to go ahead. That top one there is all done, so let's go ahead and look at the second one here. 1 minus 2 plus nothing, negative 1. Now we're going to go here, nothing, negative 1, nothing, negative 1. So now we're going to take a look at the product BA. Like I was saying before, you have to be very careful that you put these in the right order. This one wants the B times the A, so we're going to have to write the B matrix first, negative 3, 1. Across the second one, it's 1, 2. And then the A matrix. B goes first, A goes second. Does the order of things really matter? Absolutely, because the columns and the rows have to match up just the right way. This is 2 by 2, and this is 2 by 2. So yes, they can be multiplied this way, and our answer is going to be 2 by 2. Why don't you go ahead, pause this video, and see if you can try some matrix multiplication. Okay, hopefully you got the right answer. Across the top one here, it's going to be negative 6, 1, and then 2 and a 9. Okay, let's take a look at a word problem. One of the reasons why we do matrices is it can handle a lot of information in a nice form. So matrices sometimes can get up to 20 by 20 if need be. A clothing store is selling men's shirts for $40. The silk ties are $20 and the suits are $400. Last month, they had sales consisting of 100 shirts, 200 ties, 50 suits. Set up this information in matrix form, okay, and we're going to find the total revenue. So let's go ahead and make a matrix here. I'm going to put all the costs in a matrix, and then I'm going to multiply the costs by the amounts. And I think that would certainly work. So what I'll do here is put 40 and 20 and 400. Okay, we have to be careful that we do this the right way. So if this is 3 by 1, then our amounts are going to have to be matching. So I'm going to make it be 1 by 3. So how many of the shirts? 100 shirts, 200 ties, 50 suits. So that would certainly work. Okay, and so our answer is going to be a 3 by 3. 3 by 3. It's going to have 1, 2, 3, 1, 2, 3, 1, 2, 3. Does that seem like a great way to find the total revenue? That's going to give me 9 values. We did nothing wrong here. 3 by 1, 1 by 3. That is perfect. Except I don't think that these dimensions are going to make the right revenue here. I don't want 9 numbers. I want 1 number. I want the revenue. So actually, this is not the right setup. Let's try this again. What if I did the costs? What if I did the costs 1 by 3? 40, 200, 20, and 400. This is 1 by 3, which means I'm going to have to do the amounts as 3 by 1. The amounts are 100, 250. If you have a 1 by 3 and a 3 by 1, okay, I know that will work, and the answer is going to be a 1 by 1. Does that make sense to determine the total revenue for the sales? I think this is the right setup. Okay, and I know that this happened one year in ACT where the students had it narrowed down to these two. They knew the numbers had to go to a matrix, and it wasn't calculate, it was just set it up. So you had to pick the right setup. So they had a 50-50 chance. But you have to think about what kind of answer are you going to get. What's 40 times 100 plus 20 times 200 plus 400 times 50? How much revenue is this store going to make? $28,000. Okay, I hope you enjoy matrices.